Good morning to all. So, in previous lecture, we have studied about the different stages of the combustion in SI engine. Okay, so basically we have learned that there are three stages of the combustion. Okay, that is first stage is ignition lag or a delay period. Okay, and the second stage is flame front propagation stage or the just propagation stage. We can say that. Third stage is after burning. Okay, that we have learned. Now today we will see what is the flame front propagation and what are the different actually uh, parameters which are affecting on this particular flame front propagation. Okay, and after that we will see what is the knocking that is takes place inside the combustion chamber in the SI engine. Okay, so let us start today's lecture. I hope you have seen the previous lecture, okay, that is uploaded on Google Classroom. So what is this flame front? So the two important factors which determine the rate of movement of the flame front across the combustion chamber, and that two important factors are, first is reaction rate, okay, and second is transposition rate. Okay, so what is reaction rate? It is the result of purely chemical combustion process in which the flame eats its way into the unburned charge. Okay, and what is transposition rate? It is due to the physical moment of the flame front relative to the cylinder wall and is also the result of pressure differential between the burning gases and the unburned gases in the combustion chamber. Okay, so these are the two important factors that will affect on this particular flame front propagation. So when you the question is asked in the examination, what are the different factors that affects on the flame front propagation? So in that, two important factors that we have to mention, that is reaction rate and transposition rate. Okay, so along with these two factors there are another number of factors are there, but first we will see what is this reaction rate and what is the transposition rate. Okay, and whatever another factors we are going to discuss, that factors will definitely affect either reaction rate or either transposition rate or both. Okay, so we will discuss in that in detail. Okay, so let us see about this particular two factors. Okay, so if you see this, that is this is the A to B, that is ignition delay period. Okay, and as already we have discussed that this in this particular A to B process, it is also called as a chemical uh, process. Okay, B to C is nothing but your transposition process, and C to D, okay, that is the after burning. Okay, that is the mixture of these two processes. So if you see this particular A to B, so in this A to B process, what is happening here? There is a low transposition rate and low reaction rate is available. Okay, this is the area 1. If you see this B to C process, so here increased flame propagation in this process, flame propagation is increased. Okay, the velocity of that particular flame front is increased in this particular process. High transposition rate is available, high reaction rate is available. Okay, that is the area number 2. Okay, you can see CD, that is the low transposition rate or the low reaction rate, that is from C to D, and this is area number 3. Okay, now let us discuss about this area 1. So the flame front progresses relatively slowly due to a low transposition rate, comparatively small mass of charge burned at the start. Okay. The low reaction rate plays a dominant role, resulting in a slow advance of the flame. The lack of turbulence reduces the reaction rate and hence the flame speed is also reduced. So if there is no turbulence inside the combustion chamber, the reaction rate will be very much less, and hence whatever flame speed is there, that will be very less. Okay, and this ignition lag will be higher in that case. So what is our target? We have to reduce the ignition lag as much as possible. Okay, remember this. Now area 2, as the flame front leaves the quiescent zone, and proceeds into more turbulent areas. Okay, that is area number 2, where it consumes a greater mass of mixture. It progresses more rapidly and at a constant rate, that is from B to C. Okay, and the last, that is area CD. The volume of unburned charge is very less towards the end of the flame travel, and so the transposition rate again becomes negligible, and thereby reducing the flame speed. Okay, so the reaction rate is always reduced again, since the flame is entering a zone of relatively low turbulence, that is C to D. Okay, so this is about the transposition rate and the reaction rate, okay, or the reaction process of the transposition process. Okay, now let us see other factors influencing the flame speed. Okay, so this flame speed is very much important parameter, okay, to uh, for the turbulence, or the, sorry, for the knocking is considered. So what are the different factors which are affecting on this flame speed, that we have to see first. Okay, so the most important factors which affect the flame speed are the turbulence, the air fuel ratio, temperature and the pressure, compression ratio, engine output and engine speed. So just if you remember these only parameters, okay, for the flame speed, so that same parameters we have to write for the knocking also. So how, that we will see next. Okay, so let us discuss about this turbulence. What is the turbulence? Actually, it is the random movement of the molecules, okay, which are present in the combustion chamber. Okay, and due to this random movement of the turbulence, or the rapid movement of the turbulence molecules inside the combustion chamber, what will happen? They will get mixed with each other, and due to this, the flame speed will definitely increase and proper combustion may take place. So the flame speed is quite low in the non-turbulent mixtures. Okay, if there is a no turbulent mixture available, then the flame speed will definitely, it is lower and increases with increasing the turbulence. So design of combustion chamber, which involves the geometry of the cylinder head and piston crown, increases the turbulence during the compression stroke. Okay, remember this. This is very important point. So just what we have to do, as turbulence increases, the speed also increases. This particular relation we have to keep in mind. Okay, now again, turbulence increases the heat flow to the cylinder wall. It also accelerates the chemical reaction by increasing the rate of contact of burning and unburned particles. The increase of flame speed due to turbulence reduces the combustion duration and hence minimizes the tendency of abnormal combustion. Okay, तो exactly होता क्या है इसमें, due to increase in flame speed due to turbulence, what will happen? Abnormal combustion may be avoided and hence we can avoid knocking. Okay, however, excessive turbulence, if you increase the turbulence beyond certain limit, then what will happen? It may extinguish the flame and resulting in rough and noisy operation of the engine. Okay, so now we have to increase the turbulence, but up to certain level. After that, it may be dangerous for the combustion. Okay, now next parameter, that is fuel air ratio. What is this fuel air ratio? We have already discussed about this fuel air ratio. There are three types of this fuel air ratios: stoichiometric ratio, okay, a rich mixture, or the chemically a linear mixture. Now the fuel air ratio has a very significant influence on the flame speed. The highest flame velocities, okay, are obtained with somewhat or slightly richer mixture. So if you see here in this case, so this is a linear mixture and this is the richer mixture. Okay, and what is this? This is the time required for the to reach the velocity or that particular flame front to the another end. So if you see here at this particular point A, so this is the very much less time. This is the minimum time, okay, required to travel this flame front to the another mixture, or to the other end of the mixture. Okay, so the time is less means what? Velocity is definitely higher. So when velocity is higher, the time required will be definitely less. Okay, within less period of time, total combustion may takes place. Okay, so this is the relation that you have to remember. So when the mixture is made linear or richer from the point A, the flame speed decreases. Less thermal energy is released in the case of lean mixtures, resulting in lower flame temperatures. Very rich mixtures lead to incomplete combustion which results again in the release of the less thermal energy. Okay, so we have to provide a optimum value of the richness or the leanness of the air fuel mixture. Okay, so just remember, slightly richer mixture can be helpful to increase the speed of the flame inside the combustion chamber. So this is the second parameter. Now, I hope you are getting this. Okay, the third parameter, that is the temperature and pressure. Okay, so flame speed increases with an increase in the intake temperature and pressure. Definitely, okay, when the intake temperature and pressure will increase, definitely the homogeneous mixture will be formed inside the combustion chamber, and it will definitely help to uh, increase the flame speed. A higher initial pressure and temperature may help to form a better homogeneous or air vapor mixture, which helps in increasing the flame speed. So this is possible because of an overall increase in the density of the charge. Now let us see, this is very important parameter again, compression ratio. A higher compression ratio increases the pressure and temperature of the working mixture, which reduce the initial preparation phase of the combustion, and hence less ignition advance is needed. So increased compression ratio reduces the clearance volume and therefore increases the density of the cylinder gases during the burning. Increasing the density increases the peak pressure and temperature, and the total combustion duration is definitely what will happen, reduce. Thus, engine having higher compression ratios have higher flame speeds. Okay, so remember, to increase the speed, flame speed, we have to maintain the higher compression ratios. Now, next parameter is engine output. Okay, so with the increased throttle opening, so if you open the throttle valve more, what will happen? More charge will enter into the combustion chamber. The cylinder gets filled to a higher density. The cycle pressure increases when the engine output is increased. When the output is decreased by throttling, the initial and final compression pressures decreases. The dilution of the working mixture increases. The smooth development of self-propagating nucleus of flame becomes unsteady and difficult. The main disadvantage of SI engine are the poor combustion at low loads and the necessity of mixture enrichment. Okay, that is 1.2 to 1.3, which causes wastage of fuel and discharge of unburned hydrocarbon and the products of incomplete combustion like carbon monoxide, etc., in the atmosphere. Okay, and the last parameter, let us see, that is engine speed. Okay, the flame speed increases almost linearly with the engine speed, since the increase in engine speed increases the turbulence inside the cylinder. So when engine speed increases, turbulence increases, and when turbulence increases, flame speed increases. The time required for the flame to travel the combustion space would be half. Okay, and if the engine speed is double. Okay, so these are the different parameters that are affecting on the flame speed and which are directly affecting on the knob. So I hope you understand what are the different factors that are affecting on the flame speed. Okay, thank you very much. We will meet in the next lecture.